Hey, so in this video, we're going to find the three angles of a triangle shown in this figure. Now, what we notice is this isn't a right triangle, this is an oblique triangle. And so if you're confused about what an oblique triangle is, then see my video, What is an Oblique Triangle? And it'll help explain it. So when you're given three sides of an oblique triangle, none of the ratios in the law of sines would actually be complete, which means that you're going to need to use the law of cosines instead. Again, so when we're given a side, side, side of an oblique triangle, that means that we're going to have to use the law of cosines. So let's talk about what the law of cosines is. Okay, so here we see our law of cosines, and that there are two forms. We have standard form and an alternate form. And so really it just comes down to what are you more comfortable using, or whether you're looking for a side or an angle. So the standard form is great because it's already set up to find the sides, and the alternate form is great because you're one step away from setting up to find the angles. So let's head back to our problem. It's a good idea first to find the angle opposite of the longest side. So our longest side here is side B, right? So we actually want to find our angle B first. So because we're looking for an angle, we really want to use the alternate form of the law of cosines here. And so we can go ahead and we can plug in what we have and solve. All right, so now we have the cosine of B equals 8 squared plus 14 squared minus 19 squared, all divided by 2 times 8 times 14. And when we plug that into our calculator, we see that the cosine of B is going to be approximately negative 0.45089. Now, because the cosine of B is negative, we know the angle B is going to be an obtuse angle, right? So now we're going to go ahead and we're going to take the inverse cosine of both sides, and what that's going to allow us to do is to actually solve and find what is the measure of angle B. And so when we take the cosine, or the inverse cosine rather, those cosines are going to cancel out, and we're going to get to the measure of angle B is 116.80 degrees. And now that we have an angle measure, it's actually easier to use the law of sines to finish this problem, like to determine the measure of angle A. And here we can see that we're using the reciprocal law of sines because we are looking for our angles. So we're going to go ahead and set that up. All right, so we have the sine of A over 8 equals the sine of 116.8 divided by 19. So to get the sine of A by itself, we're going to go ahead and we're going to multiply both sides by 8. That's going to allow us to cross those 8's off. And so we have the sine of A equals 8 times the sine of 116.8, all divided by 19. Now to get the A by itself, we're going to take the inverse of sine of both sides so that our sines cancel out. And we get that the measure of angle A is going to be about 22.08 degrees. And now it's a triangle, and we know that the sum of the angles of a triangle add up to 180. So if we add our 116.8 and our 22.08, and then take that answer, we're going to end up getting 41.12, which is going to be our measure of angle C. 41.12. And now we found all three angle measures like we needed to.